So we've already discussed how to find the area of a rectangle and how that applies to the real world. But what we haven't discussed is how to find the area under a curve. You can see that this is not so easy to do. What we can do though is draw a bunch of rectangles inside of it and then use the areas of each rectangle, add them up, and that gives us an estimation of what the area under the curve would be. So that's what we're going to do on this video. So our topic is called Riemann sums, and that is Mr. Riemann right there, and his head is cold, so I'll give him a hat. And we have three Riemann sums: the LRAM, the MRAM, and the RRAM. Well, L stands for left, M stands for midpoint, and R stands for right. The LRAM is the left endpoint rectangular approximation. The MRAM is the midpoint rectangular approximation, and the RRAM is the right endpoint rectangular approximation. But I'm really just going to call them LRAM, MRAM, and RRAM. In this video, let's just talk about A and C, and we'll talk about MRAM another time. All right, so find the area bounded by the following curve. So this red graph is the graph of x squared plus 1, and we want to find the area in the interval of 1 to 3. So in other words, we're trying to find the area of the curve from 1 to 3. Okay, how would we find the area of that? Well, we've already discussed this briefly, but we're going to create rectangles. How many rectangles are we going to do? Well, this problem asks us to do 4 subintervals, which is a fancy way of saying 4 rectangles. So here's my interval right here. From here to here is going to be possibly a rectangle. From here to here, possibly a rectangle. Here to here, and then here to here. See how I've gone from 1 to 3. But the question is, what's the height of the rectangle going to be? Well, when we're doing the LRAM, we choose these 4 points to the left. We do not choose the one on the right. And what do I mean by that? Well, I go to my 1.0 and I draw a line straight up until it hits the curve. That will be my height. And then I'm going to go right over. Same thing with 1.5. I'm going to go straight up from that line until I hit the curve. And then I'm going to go straight over. Start at 2, go straight up until I hit the line, and then go straight over. And I'm going to do that one more time because to see how that's checked, I'm going to go straight up, hit the curve, and then go straight over. So those are the 4 rectangles that we're going to use to find the area under the curve, or at least estimate it. Let's see how I did. Oh, pretty darn good, eh? All right, now let's actually find the area. Again, it's an estimation, but we are estimating. So how do I find the area of a rectangle? Well, it's going to be this base times this height. Well, the base is from 1 to 1.5. Well, that's a 0.5. My height is whatever my y value is right here, or we can think of that as f of 1. Again, we have a 0.5 for this width. We're now on the next rectangle. And the height of this rectangle is going to be f of 1.5. Don't overthink that. That's just the y value associated with those x values. Again, plus 0.5 because we've got another 0.5 right here. And this height is going to be an f of 2. And then 0.5 for the last one, that's my width, and my height is going to be associated with that 2.5, f of 2.5. Well, some of these we can do in our head, right? F of 1, we just plug in 1 here. 1 squared is 1 plus 1 is 2. So it's going to be 0.5 times 2 plus 0.5. What do we get when we plug 1.5 in? Well, I actually am going to have to use my calculator on that. I get 3.25 plus 0.5. What do I get when I plug 2 into my equation? So instead of 1.5, I'm plugging in 2. Well, that's 2 squared plus 1 is 4 plus 1 is 5. So I'm just plugging into the equation. And last one is f of 2.5. Well, plugging 2.5 now, I get 7.25. And you can think about it. You can say, hey, Miss Sorensen, why didn't we just look over here and say, oh, that's a 2, and oh, this is a 5. Well, it's nice for those problems, but this one, did you know that was a 3.25 and that this one was a 7.25? Probably not. That's why the plugging in method into the original equation is best. So now we just plug that in the calculator and we get our answer. And here I get 8.75, and we're talking about area, so this is going to be units squared. And we'll talk about this later, but this is definitely an under approximation, an underestimate, because look at all this space that we did not account for in our area estimate, and also this right here. So we're definitely an underestimate there. Okay, now let's look at the title of this slide. This is RRAM. And again, we're talking about 4 subintervals. So we're talking about from 1 to 3. Okay, and this time I'm going to use my right values, 3, 2.5, 2, and 1.5. So I'll use this one, this one, this one, and this one, but I won't use the y value there. All right. So I like to start on the right side here. I go all the way up from 3 until I hit the curve. I missed, but that's all right. And I go over, and then I go down till I hit 2.5. Okay, same thing here. I go up to 2.5 as soon. I could do different colors so you can see me doing that. I go up 2.5 until I hit the curve. I stop, and then I go over. Okay, now I'm going to do a different color so you can see me doing that. I'm going up 2.0 until I hit the curve, go over. Okay, and then last rectangle, I'm going to go up the 1.5 until I hit the curve and go over. Notice how I don't use the 1.0 in terms of my height of my rectangle. All right, so again, our red, what is this distance right here, that value? Well, we know it's 0.5, but what if I didn't show you a picture? How could you find out that that was 0.5? Well, for the width, what you can do is do 3 minus 1. So you're basically subtracting your upper bound minus your lower bound, and then you're dividing it by the number of subintervals, or the number of rectangles you want. Well, 3 minus 1 is 2, divided by 4 is a 0.5. So if I said do this without a picture, you subtract your upper bound minus your lower bound and then divide by your subintervals. All right, so now we know it's going to be 0.5, and this time it's actually going to be f of, our height is actually this value, which is f of 3, plus 0.5 times f of 2.5, plus 0.5 times f of 2, plus 0.5 times f of 1.5. Notice how I don't have an f of 1 because there's an x here, but I have an f of everything else. And similarly, going back to this problem, notice how we did not have an f of 3 here. It just stopped at 2.5 because this was LRAM. We were using this one, this one, this one, this one, and not that one. So that's going to be the difference in your formula. And again, we know what f of 3 means. It means just plug 3 in here. So we're going to have 0.5 times 3 squared is 9 plus 1 is 10, plus 0.5 times f of 2.5. So 2.5 squared plus 1 is 7.25. Okay, plus 0.5 times f of 2 is 5, plus 0.5 times plugging in 1.5. 3.25. All right, what's our answer we get? I get 12.75 units squared. And notice that that's much bigger than the 8.75 we got. But this one's an overestimate, meaning this we should not have counted that, or that. okay? Don't falsely believe that we should just take the average of both. That's actually not true because we don't know what's going on with this curve right here. It's not necessarily cutting it in half. All right, so that is the RRAM, and we've already discussed the LRAM. So thanks for watching. Good luck on the homework.